Hey Earth Science students, here we are with our second video for this little block of assignments. We're going to be talking about global winds. We talked about ideal gas law just now, and the reason that we have these global winds is due to that ideal gas law. We're going to be talking about polar easterlies, prevailing westerlies, trade winds, how it affects our climate, how it affects our weather. So without further ado, let's just get right into it. All right, so why do winds happen? PV equals nRT. Okay, the ideal gas law, pressure volume equals number of moles times the gas constant times the temperature. Okay, so winds tend to move from places of high pressure to low pressure. So if you've ever had an air compressor, okay, so we compress the air inside the tank, okay, and so when we want to use that, okay, we use this ideal gas law idea to compress the air so that we know that when we press our nozzle that the air is going to flow out because it wants to go to a place of low pressure. Okay. On top of that, that can also mean moving from something of high temperature to low temperature. Okay, so if in the winter you've ever gotten yelled at for leaving the door open and letting all the hot air out, okay, that's because all of the warm air is trying to get to a place of low temperature. Okay, so again, it's not that the cold air is flowing inside, the warm air is flowing outside. That's a very, very common misconception on how air flows. Okay, so think about where on Earth are there low temperatures? Obviously at our poles, right? Okay, so air is going to tend to go from the equator towards the poles. Okay, so a place of high temperature to a place of low temperature. Okay, so where on Earth are there high temperatures? Around the equator. Okay, so like I said, in general, wind blows from the equator to the poles, okay, because of this ideal gas law. All right, so let's get into our global names. We have polar easterlies. Okay, so make sure that these names always have like two things that go with them, or at least these first two do. Polar, meaning that these are going to take place in the poles. Easterlies mean that they're going to be coming out of the east. Okay, so excuse me, they're going to be blowing from east to west. Okay, so these begin as dense polar air sinks, okay, because remember we know all about convection because of our work with the sun and our work with ocean currents. That cold air is going to sink, warm air is going to rise. The cold air descends and moves from the east as the earth rotates, so it's coming from east to west, so from where the sun comes up to where the sun goes down. Okay, that's typically opposite of the kind of wind that we get in North America. These are weak and sporadic. They're infrequent and patchy. Okay? They can be really, really strong in places and really, really weak in other places, but they are sporadic as they move across our poles. The prevailing westerlies are what we typically have in where we live here in Colorado and here in North America. We have our prevailing westerlies. Okay, they move from west to east. Okay, so they come out of the west and they move east and actually move up towards the poles because of how they interact with the polar easterlies. Steady winds that move much of the weather across the United States. If you've ever noticed, we almost never get storms that come from the east. Most of the time, there are some special cases where we do. Most of the time, all of our weather is going to come over the mountains, and that is because of the prevailing westerlies pushing the weather that direction. All right, and then lastly, we have trade winds. These winds are going to be over the equator. Okay, they're two circulation belts of air. Okay, so basically they're going to be pushing away from the equator in both directions. So if you imagine the equator is here, on top they're going to be pushing away, and on bottom they're going to be pushing away. Okay, so they're two circulation belts of wind. Air in these regions sinks and moves toward the equator in an easterly direction. So again, these are going to be going from west to east. Okay. Okay, when the air reaches the equator, it warms, rises, and moves back. So basically, we're going to talk about these things called Hadley cells here in a second, where the warm air rises and then it gets far enough from the equator into the atmosphere that it cools back down and comes back down, gets heated up by the equator again in this constant motion of air. Okay, here is our little picture of what is happening. Okay, you can see our polar easterlies are coming here from east to west. Our trade winds are going east to west. Our prevailing westerlies are going west to east. These are the Hadley cells I was talking about, where the warm air is here and it gets warmed up and it cools down. Let me see if I can put my cursor on it. Whoops. Okay, right here. Okay, so they go in these little pockets that we call Hadley cells. All right, so on top of that, we have things called jet streams, and these are going to be narrow bands of fast wind located in between our barriers for all of our other types of global winds. Okay, so there's a jet stream in between the prevailing westerlies and the polar easterlies, and then there's another jet stream between the trade winds and the prevailing westerlies. Its speed varies with the temperature difference between the air masses and the wind zone boundaries. So between the polar easterlies and the prevailing westerlies, it depends on how drastic the temperature change is between those two places. Okay, so the two that you need to know are the polar jet streams. They separate the polar easterlies and the prevailing westerlies. They also move west to east and are also attributed to moving our weather systems. The subtropical jet streams, they separate the prevailing westerlies and the trade winds. Okay, and like I said at the bottom, weather systems generally follow the path of these jet streams. Now, on top of that, we're also going to be talking about weather here not this week, but next week, or next on Wednesday, or on Thursday when I release new content. We're going to be doing stuff about severe weather like hurricanes and tornadoes and stuff like that. But before that, we're going to talk about weather fronts. Okay, I have a reading for you to do after this video, just like we had a reading about the ideal gas law in atmospheres. Okay, you're going to read about what a cold front is, a warm front is, a stationary front, and an occluded front. It's kind of going to tell you about how you read a map when they do their whole weather on the news. So we have high pressure systems, low pressure systems, we have fronts, and that sort of thing, and what that all means as far as weather. So make sure that you guys read that. All right, so let's talk about pressure systems real quick. Okay, air always flows from an area of high pressure to low pressure. Okay, so if you have a low pressure system, okay, then air is going to flow in that direction. If you have a high pressure system, then it's going to flow in that direction as well, or it's going to flow away from that direction. Okay, sinking or rising air combined with the Coriolis effect results in the formation of rotating high and low pressure systems. One thing that you need to notice is that with the low pressure system is that the spiral is going inwards towards the center, and with the high pressure system, they're going outwards away from the center. Okay, air in these pressure systems move in a circular motion around either a high or low pressure center. Okay, the Coriolis effect is what causes these things to not move in straight lines because we're spinning. The air currents are going to spin as well, just like our ocean currents do. Okay, so in a low pressure system, things that you need to know is that air rises. Okay, so air rises, it spirals towards the center, and these are the things that are going to typically bring bad weather. Okay, low pressure systems are the things that bring bad weather. Okay, clouds form on the top, that's when we have rain, that's when we have tornadoes. You can kind of see how this would form a tornado just by looking at it. If you can see the spiral inward, that's what's happening. Hey, high pressure systems, air sinks and it spirals out of the center. This typically brings really, really, really good weather. No storms, sunny, very few clouds, that sort of thing. Okay, and then again, the direction depends on the Coriolis effect. Okay, so some things we're going to talk about. We're going to talk about tornadoes, we're going to talk about snowstorms, thunderstorms, and that sort of thing, and how you can look at a map and kind of determine what is going to happen where. So be on the lookout for that for our assignments on Thursday. Remember that your unit test is coming up next Monday, so make sure that you're staying on top of your work. We only have I think I only have 7 more posts until the end of the year, okay, including this one. So 6 more after this one, and then we're going to take our final on that very last Monday, and we will go from there. All right, well, thanks for watching.